Welcome to this video where we'll be discussing P-channel and N-channel MOSFET transistors. We'll explore how they work and their various applications. MOSFET transistors are a type of transistor that relies on the electric field effect to control current flow. They are fundamental in modern electronic circuits. A MOSFET consists of three main terminals: the gate, drain, and source. It also includes an oxide layer to insulate the gate from the rest of the transistor. The main difference between P-channel and N-channel is the type of charge carriers that control current flow. In an N-channel, electrons move from the source to the drain, while in a P-channel, holes move. When a positive voltage is applied to the gate of an N-channel MOSFET, an electron channel forms between the source and drain, allowing current to flow. In a P-channel MOSFET, the opposite occurs. When a negative voltage is applied to the gate, a channel of holes forms between the source and drain, allowing current to flow. N-channel MOSFETs are used in power conversion circuits and in applications requiring high current. P-channel MOSFETs are mainly used in low-voltage applications and protection circuits. In terms of performance, the N-channel is more efficient at conducting current due to the faster movement of electrons compared to holes in the P-channel. Both types are often used together in complementary circuits to create efficient electronic switches. Choosing the right type depends on the specific application. If higher efficiency is needed, the N-channel is used. If low voltage is important, the P-channel is the better choice. In conclusion, P-channel and N-channel MOSFET transistors play a vital role in modern circuit design. Understanding their differences helps in selecting the best one for each application.